Hello everyone. Today we are going to discuss the last problem of weekly contest 404 Leetcode, which is find minimum diameter after merging two trees. So the problem statement is quite simple. We are given two trees, uh, represented in two edges array, edges 1 and edges 2. We have to add a edge between any two nodes of the array, and after that we have to find the minimum possible diameter of the resulting tree. Okay. So let's take the first example. The first example is like this. The first tree is like this: 0, 1, 0, 2, and 0, 3. And the second tree is like this: 0 and 1. Okay, 0 and 1. Now there are multiple possible ways to add edges between this any two nodes. That is the total number of edges we can make is that 4 into 2. Okay, and among these 8 possibilities, so the total time complexity of adding any edge between any two nodes is order of n into m, where n is the number of nodes in the first tree and m is the number of nodes in the second tree. So that is the brute force solution to try to add edge between any two nodes of the tree, and after that we have to compute the diameter, which is also order of n. So the overall time complexity will be order of n square into m if we go by the simple brute force way to solve this. Now let's say we are adding edge between this and this node, which is the optimal case. Then what will be the diameter? The diameter will be number of edges between maximum number of edges between any two nodes in the tree, so which is edge between 1 and this 2. So the total number of edges are 1, 2 and 3. So the answer will be 3 here. Okay, answer will be 3 here. So let's take another example. Let's say this example is kind of complicated. Let's see the example here only. So what is it? The first tree is like this: 0, 1, 0, 2, 0, 3. The first tree is like this: 0, 1, mm, 0, 1, 0, 2, 0, 3, 0, 1, 0, 2, 0, 3, and after that there are edges from 2 to 4, 2 to 5, 3 to 6, 3 to 7, 2 to 4, 2 to 5, and there are edges from 3 to 6 and 3 to 7. Okay, this is the first tree, and the second tree is same. So we have two same trees. Okay, so let me draw that also: 0, 1, 2, 4, 5, and 3, 6 and 7. 3, 6 and 7. So which which two nodes we should connect to get minimum diameter? Okay, so what is the we can obtain a tree with diameter 5 by connecting 0 from the first list with 0 from the second list. Okay, so we are connecting 0 from the first list and 0 from the second list. Then what will be the diameter? Diameter will be this one: 1, 2, 3, 4, 5, 6, I think. Why the diameter here is mentioned as 5? I think I have drawn the graph wrong, or what? Let me check. 0 to 3, 3 to 6, and there is a age from 2 to 7, not really 6 to 7. So I have drawn the graph wrong. There is no age from 6 to 7. There is a age from 2 to 7. There is a age from 2 to 7. Okay, I hope you got it. Now here the number of diameter will be from 6 to this 7. So 1, 2, 3, 4 and 5. Okay, so here that is the optimal way to connect any two nodes in this tree. So the answer will be 5 here. But now how to solve this problem and how to approach this problem? For that we have to know the diameter, what is the diameter of the tree, and how we can find the diameter of the tree. So to find the diameter of the tree, we have to find the center of the tree. Okay, so what is the center of the tree? Center of the tree means from the particular node where all the leaf nodes will have the similar kind of distance, same distance or distance plus 1. Okay, so let's say for this node, for this tree, 0, 1, 2, 0, 3 and 4. Okay, so here the center is 0, because for all the leaf nodes the distance is same, 2 and 2, but there could be some possibilities where the distance are not same. Let's say this is like that: 0, 1, 2, 1, 2, 3, and here is 0, 4, 5. Here there are two centers. Why? there are two centers, one is 0 and another one is 1. Okay, 0 and 1. So from 0, there is one leaf node with distance 3 and another leaf node with distance 2. Similarly for 1, it leaf node with that distance 3 and another leaf node with distance 1. So what we can say, if we find out the center of a tree. Let's say we have find out the center of a tree, and the center of the tree is 1. Only one center is present. Then the diameter will be 2 into 2 into radius. You can say this as radius, or the number of leaves we have removed to reach 0. Okay, 2 into, let's say, call it r. Okay, 2 into r. I will define r, how we can find r, but let's say this will be 2 into r. Okay, and here the number of leaves we have removed to get to 0 is 3. So here the answer will be 2 into r minus 1, because the diameter is 5. Okay, so here the diameter is 2 into r, and here is the diameter is 2 into r minus 1. Okay, why? If the number of centers are 1, then the diameter will be 2 into r, otherwise the diameter will be 2 into r minus 1. Now how we can find this r value? So for finding the r value, let's say we have something like this, 0 1 2 and here 0 3 4. Okay, for finding the r value, the common trick is to remove all the leaf nodes one by one. So currently the graph has two leaf nodes, so we'll remove this leaf node and this leaf node and increment our counter value by 1. Now after removal of these two leaf nodes, we have another two leaf nodes 1 and 3, so we'll remove them also by 1. So our counter will be incremented by 2. Now if the now the new leaf will be 0. If the leaf size is 1, then we will break. Okay, if the leaf size is 1, will break. So the count is the r value is 2 here. Now let's say we have something like this, 0 to 5, and let's say 1 2, and let's say this is 3 and 4. Okay, now let's say we remove this node and this node. Okay, counter value will be 1. This node and this node, the counter value will be 2. Now the leaf size of the leaf are 2, so we are not breaking. So here removing this and this, so our counter value will be 3 now. So r is 3 here and r is 2 here, so our diameter here will be 4 and the diameter here will be 2 into 3 minus 1 5. So that is the way to find diameter of a tree. Now there could be other approaches to find diameter as well. One common approach to find the maximum distance node from a particular node, we can start DFS from any node, and we found out the maximum distance node from that node, and after that we start DFS from that node only and find the maximum distance node from there. That is one common approach. But why we are using this approach here? Why this approach will give us will help us, okay, in the further solving the problem? Why? How the r value will help us? Okay, r value will help us because let's say we have find out r1 from the first tree and r2 from the second tree. Okay, r1 means what is the maximum distance node from the center of the tree, and r2 means what is the maximum distance node from the center of the tree in the second tree. So uh, if we add the two centers, okay, if we are adding two centers, then the total the diameter of the resultant tree could be r1 plus r2 plus 1. Okay, the diameter of the resultant tree could be r1 plus r2 plus 1, because the maximum distance node from the center is r1 in the first tree, and the maximum distance node in the center from the second node is r2. So r1 plus r2, and here there is a edge from the two centers, so r1 plus r2 plus 1. Now you are saying that r1 plus r2 plus 1 is our answer. I also thought that the r1 plus r2 plus 1 is our answer, but here is a catch. There, let's say one tree has diameter which is greater than r1 plus r2 plus 1. Then this assumption will break. So we have to take the maximum of r1 plus r2 plus 1 and the diameter of the first tree and the diameter of the second tree. The maximum of these three will be our answer. Okay, so let's jump into the code. The code is quite straightforward. So this max distance will this max distance function has two things to do. It has double responsibility. The first responsibility will be to find the radius r value, and the second responsibility will be to set the answer value as the maximum of answer and the diameter of the current tree. So this has two responsibility. This second one, setting answer, it is doing separately, and it is returning the r value to us. Okay, so how we are finding the r value? Initially we are initializing, we are setting degree I as 0 for all the nodes, and setting the adjacency list, uh, clearing the adjacency list. And here when there is age from x to y, we are incrementing the value of degree of x, and we are incrementing the value of degree of y. Okay, and we are pushing y in the adjacency list of x, and x in the adjacency list of y. Now initially leaves, this leaves, and we are checking if every leaf node will have the degree 1. Okay, every leaf node will have degree 1. So if degree I equals to 1, then we are inserting that in our leaves node. Now while the leaves dot size is greater than 1, this is our new leaves. This is our new list. Now we are iterating over every leaf, and the neighbor of every leaf, and if we are decrementing the value of degree of every leaf. If the degree of the neighboring node is 1, then we are pushing that into the new leaves. Okay, and we are incrementing the value of counter when we have processed all the leaves, and we are setting new leaves as the current leaves. Okay, now if the leaves dot size is 0, then we are setting, this is the diameter, we are setting answer as maximum of answer comma 2 into count minus 1. Otherwise if there are more leaves present, sorry, if there is only one center, then we are setting answer as answer comma 2 into count, and we are returning count from here. And we are finding r1 of the first tree and r2 of the second tree, and we are setting our answer as maximum of answer comma r1 plus r2 plus 1. I hope you get the explanation. If you have any doubt in any part of the explanation or code, you can always ask in the comment section. I will try to provide the code link in the description box. If you find this video helpful, please like the video and subscribe to my channel, and also share among your peers. Thank you.